All right. So our demo looked like this. So we started out with a strip of rubber band. Before loading, what was the length of the strip? Okay. So 8.08 millimeters. What was this? Okay, 3.07 millimeters, and then this one. What was this one? 1.97. And then after loading, it's stretched out a bit. What was the length of the black strip? 5.3. And the new width, 2.61. And now we're just going to go through these calculations. We know that Young's modulus, by that definition I gave you, has to be equal to the axial, and so I'm just calling this axis the x-axis. Okay, so it has to be equal to the axial stress divided by the axial strain. The axial stress is the force, 1.55 newtons, divided by the cross-sectional area. The cross-sectional area is, can someone multiply this out? So, and remember that the cross-sectional area has to be before the deformation. Yep. Okay, yes, so you're always, you're taking the stress with your cross-sectional area as the unloaded cross-sectional area. Okay. Again, the fact that that would be something to consider, to be concerned about if we weren't dealing with small deformations. You'd have to think about that more carefully, but we're just going to assume that the deformations are small enough that that's a good approximation. Okay, so 0.00307 times 0.00197 meters. That's the cross-sectional area of the cross-section. It's the cross-sectional area, so it's like a cross-section like this, while the force is going up and down. Okay. I guess just tell me, what's 3.07 times 1.97? E to the -6, I think it should be, right? Okay. And that's meters squared. And so what do you get for the axial stress?
2.56.
Okay, and that's pascals. And now the axial strain is 9.53. And remember, this is non-dimensional, so it doesn't matter what, we can use millimeters for this, that's fine. So 9.53 minus, was it 8.08? Is that what it was before? Divided by 8.08. So what do you get for that? 0.179, no units. Does it make sense that both of these would be positive? If you think about the sign conventions. Yeah, it's in tension and it's being stretched. So both of those should be positive. And so Young's modulus is 2.56 times 10 to the fifth divided by 0.179. And what do you get there? Okay, so we're halfway there. That's Young's modulus. And now we have to calculate Poisson's ratio. We already calculated the strain in the loading axis, so now we just have to calculate the strain in an off axis. So we'll calculate the Y strain. So Poisson's ratio is negative EYY divided by EXX. EYY is equal to, so after the deformation, we're doing this one now, so 2.61, because we're doing the off-axis strain. So 2.61 minus 3.07 divided by 3.07. What do you get for that?
Negative 149,
0.15. What did we get for the other one? Okay, that's not looking good, but we'll keep going. So then Poisson's ratio is equal to negative 0.15 divided by the axial strain, 0.179. And so what do you get there? 0.838, which is outside of the allowable range. I think there might have been some experimental error in there somewhere, but yeah, I mean, I'm sure we could. Not really allowable, but okay. For our purposes, we'll just go with that. So so the material is defined by E equals 1.43 times 10 to the 6. Poisson's ratio is equal to 0.838. Young's modulus, by the way, is pascals. And so why don't, by Monday, would you try to find time to just plug these values into the compliance matrix, and then we'll use that for calculations, like in a couple example problems on Monday. Okay. So plug this into the formula for the compliance matrix. Um, and then any stress at a point allows the calculation of the strain at that point. Okay. Any questions about the sort of approach to calculating those two values?
Could, when you were doing the off-axis one, could you just make it a little more accurate? Could you measure both ways and just take the average?
Yeah, I think that would probably be a good, I mean, seeing what our results were, I think something like that would be a good way to put extra care, caution into that. I wouldn't be surprised too if the hardest thing to measure there, I think, was the length of that black strip, because I couldn't put it against anything. I'm just sort of eyeballing it. So I think I would probably try to come up with a better way to do that. Yeah, so that would have been a better way to do it. I just, I wasn't sure the calipers would get that wide, really. But yeah, that would probably be more accurate. Yeah.
Why do we get more than 1.5? This is 0.8. 0.5 should be
Yeah, so that's what I was just saying, is that I think it was just problems in my measurements that gave us unrealistic answers. I think if we redid it, fix some of the problems, the difficulties that I saw at that time, I'll bet we would get better answers. Any other questions? Okay, have a good weekend.